All right, everyone. So today we will discuss AIET 1 of class 12th. All right, the syllabus for this test was majorly determinant matrices, functions, and the entire syllabus of class 11th. Okay, so let's talk about this. This was a good paper as far I analyzed it. So first of all, I'll talk about question number 2. Question number 1 is easy. The line intersect x-axis at point A, y-axis at point B. So A and B you can find out easily, like A will be 6 comma 0, A will be 8 comma 0 and B will be 0 comma 6. And third point is origin. Now you just need to find out the in center of the triangle, which is easy now. A and B are symmetric matrices of the same order, then which of the following is not true? Now see, A and B are symmetric matrices. A and B are symmetric matrices. That means what? A transpose is A and B transpose is B. Now they're asking for which one of the following is not true. Now see, definitely it is going to be a symmetric matrix. Definitely it is also going to be a symmetric matrix. Okay, so I'll talk about this one first. So let X is AB minus BA. So X transpose will be what? AB minus BA transpose. That is AB transpose minus BA transpose. That is AB transpose is B transpose A transpose minus A transpose B transpose. I use the reversal law of transpose. Now B transpose B, A transpose A minus A transpose A, B transpose B. Take minus common, it will be AB minus BA, and this is minus X. So definitely if X transpose came minus X, that means this particular matrix is a this particular matrix is a skew symmetric matrix. And they are asking for which of the following is not true, so definitely it is not true. All right. Now, this is an easy question we were just talking about. Now see, again, a very important and touchy topic every time. Got it? The question is, if ABC are non-zero, the system of equations has non-trivial solution. Now see, system is already having trivial solution. Already having 0, 0, 0 as a solution, to which we call trivial solution. Now they are saying system is also having non-trivial solution. That means system is having infinite number of solutions. So in that case, determinant of alpha plus A, alpha, 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 alpha plus B, alpha, 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 alpha plus C. This determinant should be what? C. Am I clear? Now, this value of this determinant we have to find out. Now, I'll use certain one or two operations. I use C2 को you write C2 minus C1. And also C3 को you may use C3 minus C1. So it will become alpha plus A, alpha, alpha. This will be C2 minus C1 if I do minus A, B, 0. C3 minus C1 will be minus A, 0, C. So this is equals to 0. Now, without doing much, you just expand it along any row. I'm expanding along third row. So it will become alpha times AB plus C times alpha B plus AB plus A alpha. And this is equals to 0. Okay. So alpha AB plus alpha BC plus alpha AC is minus of ABC. If you divide the entire equation by ABC, you get alpha times 1 by A plus 1 by B plus 1 by C equals to minus 1. So the option is alpha inverse. Alpha negate minus alpha power minus 1 is minus of A to the power minus 1 plus B to the power minus 1 plus C to the power minus 1. So this is going to be your correct answer. All right. Simple question hai. Always remember when the equation in 3 variables all given equal to 0. And then see 0, 0, 0 is an obvious solution in that case. Now they are saying system is also having non-zero solutions, means non-trivial solutions. So in that case, what do we do? D equal to 0. All right. Now see this one. Very popular question, variety in inverse trigonometric function, telescopic. See, Tm is given to you is tan inverse of 2m upon m raised to the power 4 plus m square plus 2. This is your Tm. This is tan inverse of 2m upon. I can write it 1 plus m to the power 4 plus m square plus 1. Now this thing. We are already aware of that its factors will be m square minus m plus 1 into m square plus m plus 1. Yes or no? So it can be written as tan inverse of 1 plus m square minus m plus 1 into m square plus m plus 1. And the numerator will consist of their difference. So m square plus m plus 1 minus of m square minus m plus 1. All right. So it will become tan inverse of m square plus m plus 1 minus tan inverse of m square minus m plus 1. This is the mth term. Now T1 is what? They are asking for summation from 1 to n. T1 is what? Tan inverse 3 minus tan inverse 1. T2 is what? Tan inverse, put m as 2, so 4 plus 2, 6 and 1, 7. Tan inverse 7 minus tan inverse 3. And soon Tn will be tan inverse of n square plus n plus 1 minus tan inverse of n square minus n plus 1. Now if you add all of them, the sum of two n terms will be, see, this will cancel. This will cancel from the next one. This will cancel from the previous one. So it will be tan inverse of n square plus n plus 1 minus tan inverse 1. See, in the options, they have used the formula once again. So I can write it tan inverse of a minus tan inverse b is tan inverse of a minus b upon 1 plus ab. So it will become n square plus n upon 1 plus a into b, that is n square plus n plus 1. So it will be tan inverse of n plus n square upon n square plus n plus 2. All right. So it is n a is the correct answer. I hope I made my point clear, and this is a very popular, and there's no rocket science in this variety. There's the same approach. Now see this one again, very interesting question. If x is cosec, tan inverse, cos, cot inverse, sec, sine inverse a lies between 0 to 1, then x square plus a square, x square minus a square, they're asking for. See, x equals to cosec, tan inverse, cos, cot inverse, sec, sine inverse a. First of all, we will resolve this. So let sine inverse a is alpha, and sine alpha is a. Now, if I consider it small triangle, say this angle is alpha, that means this is a, this is 1. So this is what? Under root of 1 minus a square. perpendicular one a, hypotenuse 1, so base is under root 1 minus a square. So from there you can say sec alpha will be what? Sec alpha will be hypotenuse upon base. So 1 upon under root of 1 minus a square. So your question became x equals to cosec tan inverse cos cot inverse 1 upon under root of 1 minus a square. Got it? Now, as a second step, now let us assume this as some beta. That means cot inverse 1 upon under root of 1 minus a square is beta. So cot beta is what? 1 upon under root of 1 minus a square. From this cot beta, what are you looking for? Cos beta. Now again make a triangle. Now if this angle is beta, this is 1. Sorry. Base is 1, hypotenuse is perpendicular is 1 minus beta square. So hypotenuse will be what? 2 minus beta square. So from this cos beta will be what? 1 upon under root of 2 minus beta square. So this is your cos beta. The question became cosec of tan inverse of 1 upon under root of 2 minus beta square. Am I correct? Now let us assume this as gamma. So tan gamma will be 1 upon under root of 2 minus beta square. So if there is a triangle, this angle is gamma, this is 1, this is under root of 2 minus beta square. So this point will be, just a moment. I made a small mistake. This is not beta, this will be A. Just in the flow, this will be A square. So this is under root of 2 minus A square. This is 2 minus A square. This is 2 minus A square. And this is also A square. So this is 2 minus A square. So this will be under root of 3 minus A square. All right. So from there, I assumed it as gamma. So tan gamma is 1 upon under root of 2 minus A square. This is your tan gamma, what you are looking for? Cosec gamma. So cosec gamma will be what? Under root of 3 minus A square. That means x is what? Under root of 3 minus A square. So if you simplify, x square plus A square is going to be 3. So x square plus A square is going to be 3. See, question is not difficult, but this is the same kind of pattern repeating in the same question again and again. So calculation is too much. The only thing you have to be little precautionary. And like I also made a mistake instead of A, I start writing beta. So these things may occur. And sometimes we may get confused, like we have to write perpendicular upon base, but we not perpendicular upon hypotenuse. So these kind of mistakes we have to take care. Otherwise, simple question it is. All right. Now see, these all are simple questions. You can handle easily. Now I will talk about this question. Locus of the middle point of the focal chord of the ellipse. All right. See, there is an ellipse. Ellipse is x square upon a square plus y square upon b square equals to 1. There is a focus, say it is AE comma 0. There is another focus minus A comma 0. This is a focal chord. They are asking for the locus of middle point of this chord, HK. So first of all, what I'll do, equation of chord with given middle point. And what is the equation? T equals to S1. So hx upon a square plus ky upon b square minus 1. This is t, and s1 will be what? H square upon a square plus k square upon b square minus 1. Now, the last thing that you have to do, chord is passing through AE comma 0. So make it pass through AE comma 0. So it will become H E upon A equals to H square by A square plus K square upon B square. That's it. So locus will be what? X square upon A square plus Y square upon B square equals to EX upon A. That's it. EX upon A. Ahmedabad is the correct answer. All right. Nothing much to do. Write the chord with the given middle point. Make it pass through the focus because it is a focal point. Now, period of the function fx equals to sine of 2 pi x plus e to the power fraction part of 2x. Now, about this sine of 2 pi x. Its period will be what? 2 pi upon 2 pi. That is 1. Yes or no? Now, its period will be what? E to the power fraction part of 2x will be periodic with the same period as the period of fraction part of 2x. So fraction part of x is 1, fraction part of 2x will be 1 by 2. Now what is the LCM of 1 and 1 by 2? 1 and 1 by 2 is 1. So this will be the period. All right. Now, like this question is, find the range of this function. Domain is what? Domain will be x belongs to -4 to 4. So range minimum value will be while x is 4 or -4, that is 0. Maximum value will be while x is 0, that is under root 16, 4. So answer will be 0 to 4. Now, if the system of linear equation this has infinite number of solution, then ABC must satisfy. Now see, what do we have for infinite number of solution? Infinite number of solution means D0 as well as D1 equals to D2 equals to D3. All should be 0. So D must be coming 0. You just have to verify for D1, D2, D3. You will get a relation in ABC. All right. Now there are a few more questions. See. Absolute value of the sum of real solutions of this equation. See, if they're talking about this equation, first of all, we will see or verify what is the domain of the function. Now for the domain, tan inverse, this value, x into x plus 1, it should be more than or equal to 0 because it is inside the under root. Now, more than equal to 0 means x will belong to minus infinite to minus 1, union 0 to infinite. Now come to this one. Because it is in under root as well as in sine inverse. This x square plus x plus 1, it should be more than equal to 0, less than equals to 1. Yes or no? Now see, more than equal to 0, it is always because its d is negative. If I check for this side of the inequality, it will come with x square plus x less than equals to 1. Less than equals to 0. That means x should lie in minus 1 to 0. Now from this and from this, see, since it is a combined question, I have to take the intersection, and if I take intersection, I get only two values, x is 0 or minus 1. Got it? Now these two values we can check manually. For x equals to 0, LHS is what? Tan inverse 0 plus sine inverse 1, which is certainly pi by 2. For x equals to minus 1, LHS is what? Tan inverse 0 plus again sine inverse 1, which is again pi by 2. So both are satisfying. Now sum is what? Sum of values of x is 0 plus minus 1, that is minus 1. And absolute value is 1. So this is your correct answer. Am I clear? Now, another question is, if the letters of the word Sachin are arranged in all possible ways and words are written out as in a dictionary, the word Sachin appears in. Now see, as such, it is a simple question, but there's a strategy. First of all, write all the letters SACHIN in their alphabetical order. So first of all, A will come, then C, then H, I, N, and S. Got it? First of all, those words will come which are starting with A. Then at these 5 places, CHINS will reshuffle in every possible way. That is 5 factorial, that is 120. Then those words will come which start with C. At the remaining 5 places, AHINS will arrange. So it is again 5 factorial, that is 1 per 20. Then H will come. Again 5 factorial, that is 120. Then I will come. Again 5 factorial, that is 120. Then L will come. Again 5 factorial, that is 120. Then S will come. This is what I also require. Now if you require this, you remove it from here. Now in S, again words will start with A. Then A, I want this, cancel. Then C, I want this, cancel. Then H, I want this, cancel. Then I, cancel. And then finally N. So this is the last word. So what will be the word appear at the serial number? So 125 times 600 plus 1. So it is 601. So word Sachin will come at 601st position. All right. Now A is a 2 by 2 matrix such that see, simple question है. You just assume A as the matrix A, B, C, D and verify. You will get 4 equations. You will be able to simplify it. All right. Other questions, if I talk about here in this question like this, 89. Fx is given as this. See, f of 1 by 100 plus f of 99 by 100 will definitely be having a correlation. That means fx plus f of 1 minus x. If you simplify it, it will be 2 times e to the power 2x upon e to the power 2x plus e plus 2 times e to the power 1 minus 2x. Sorry, 2 minus 2x upon e to the power 2 minus 2x plus e. Just take LCM in the second part and finally you simplify, you get 1. That's the entire paper is simple. All right. So this is my analysis for this paper. So you just go through it and I will say it is, this paper has towards some easier side to boost your confidence. And you must have felt highly confident after attempting this paper. All right. See, every paper you see is an opportunity. Grab it. Solve it multiple times. It will ultimately be helpful for you always. All right. So we'll come up with few more papers in the coming sessions and we will talk about them. All right. Okay. Thank you so much.